Okay, so let's get started. This, as I'm pretty sure everyone can see the screen. So these are the topics which I'm planning to cover today, but I'm pretty sure in 1 hour I won't be able to cover everything. But let's see, whatever we can cover today, we will cover. Otherwise, we will cover in the next session, probably next week. In last two sessions, we kept talking about blockchain in general. We never did we never talked about specific technology, or I should say specific terminologies related to Ethereum. Today, I'm dedicating this entire 1 hour just to Ethereum. We will talk only and only Ethereum and nothing else. And thinking about Ethereum, these were the topics which came to my mind that okay, we should start talking about these couple of topics that will make your concept more clear, that will make yourself ready to start working on Ethereum directly. Okay. So the very first term in Ethereum is Ether. I'm pretty sure everyone has heard this term Ether if you have been in this blockchain world. If not, then I will tell you. Ethereum is a multi-purpose blockchain where you can execute your transaction not only to transfer money but also to deploy contract. And what contract or smart contract is? It is just a piece of code which will do whatever functionality you want blockchain to do. We'll be talking more about the smart contract, but for now, just assume smart contract is nothing but smart contract is a piece of code which can execute inside Ethereum. And what Ether is? Ether is the currency which resides on Ethereum and has a value. It has a real dollar value on the main network. Ether more or less works in a similar fashion as Bitcoin. Just like Bitcoin, you have exchanges, you can buy Ether, you can sell Ether. Just like any currency, whatever you can do with the currency, you can do the same thing with Ether. Based on certain calculations, value of Ether is calculated, and it every day it keeps on fluctuating. It goes up, it goes down. If so, that's the crypto. Actually, if Ether is more like a cryptocurrency part. And as when we started this meetup, we know like most of the people, like I also not say most of the people, cryptocurrency is a I'll say a bit easy is, or I should say it's a one of the many use case which can be executed on blockchain. And we are not interested to talk anything about cryptocurrency here. What we are interested is other use cases which can be built on blockchain or which can be built on Ethereum.
Neeraj,
Sorry, someone was going to say I heard some noise background, so I muted everyone. But if anyone has any question,
Neeraj,
please unmute.
yeah, yeah, Neeraj, not a question. I'm just saying that please do cover some of the BFS or financial use cases as well that you come across for that.
Okay, sure. Some of the use case which can be built on Ethereum is like, let's categorize it. So blockchain or Ethereum is touching all our life, like for example, healthcare, for example, supply chain, governance, banking system, anything to do with money or anything where a contract needs to be signed between two parties. Okay, all those use cases are touched by blockchain or by Ethereum. Again, for example, a very simple use case is today, if for example land registry case. Okay, in India, if you have to buy or sell land, you know there's a whole lot of process involved. You go there, you write it on paper. There's you you go to the law office and there are advocates involved. So there's a whole lot of process involved. But at the end of that process, you get a contract or you get a paper that, okay, this land belonged to someone a day or a couple of hours ago, and now it belongs to you. And also at the same time, it's the government who has to keep a track right from day one that to whom all that land belonged to. So probably, I do not know, don't go on the numbers, like somewhere in 1947 or whenever our country got independence or whenever this law came in, right from that day till today, government have to keep a track of it, and it is a very tedious task. If you go to any of the law agencies, you will see there's a whole lot of documents. And also, you all will agree with me, there's a whole lot of corruption also involved with it, right? Someone takes someone's land, someone, it gets quite complicated to keep a track that who really owns that land. And this is one of the very good use case which can go on blockchain, because all the data which resides on blockchain is immutable. Once once a data goes on blockchain, okay, it can't be removed, it can't be deleted, and always a trail record will be maintained right from day one till today, which in turn might remove like various types of corruption. That's why you, if you will search on internet, there are lots of papers published which talk about blockchain and corruption, how blockchain is efficient, how blockchain is good enough, or how blockchain is capable to remove the corruption from the society. Similarly, wherever a contract needs to be agreed upon between two parties and a third party is involved, with the virtue of blockchain, you can remove that third party. So just between party A and party B, with the help of this blockchain system, you can come into a contract. Okay, but again, I won't talk more on the use case. Let's keep it for other section. Here, I want to especially concentrate on the technology part, that is the Ethereum, like some of the terminologies of Ethereum. Okay, so coming back to my topic, Ether. What Ether is nothing. Ether is just a currency. If you are on the main network, there is a value of ether. So make a point. If you are only on the main network, then there is a dollar value of ether. But if you are not on the main network, if you are on test network, or if you have created your own network, or you are running your own Ethereum, still ether exists, but it does not have any dollar value. Okay. So again, from the technology perspective, ether is nothing. Ether is just a currency. If it exists on the main network, then it has a dollar value. If it does not exist on the main network, then it does not have a dollar value as of today. All right, and that's it. That's what ether is. Now there's another terminology called gas. Okay, gas and ether are related to each other. As I said, on the main network, just like any currency, value of ether keeps on fluctuating. Because of certain condition, it might go up, it might go down. Okay. Also, I said before, I'm not sure I said it or not, but now I'm saying it. Everything, if you want to do anything on Ethereum, you have to execute a transaction. And this is the topic I'm going to cover in a whole lot detail. So just hold on. But for now, if you have to do anything on Ethereum, you have to do it using a transaction. For example, if you have to send Ether from party A to party B, you will have to execute a transaction. If you have to deploy a contract, you have to do a transaction. If you want to call a contract, then you have to initiate a transaction. So anything or everything you do on Ethereum, that has to be initiated using a transaction. Okay. Now, in order to execute this transaction is not free. On the main network, it will cost you. So if you try to deploy a contract, or if you want to do anything on the main network, there's a cost related to it. These, as per the white paper and yellow paper of Ethereum, they said that, okay, they wanted one thing, yeah, they wanted to keep some cost on transaction so that no one misuse it, because Ethereum is a global computer. where when you execute a transaction, it gets executed on all the miners around the world. So everyone is doing something in order to execute a transaction. And they Ethereum, as per the white paper, they do not want anyone to misuse this. So what they said that okay, every transaction will cost you something. At the same time, if suppose they would have said that okay, every transaction, just for the sake of don't go on numbers, if for every transaction it will cost 1 ether, and I said there's a dollar value of ether, so it might be that today value of ether is $6, tomorrow it might go to $24, so it will keep on fluctuating, and that is not good. Then what will happen is that you won't execute transaction on Ethereum until unless the value of transaction goes down. So you see, right, like today the same transaction might cost $12, tomorrow it might cost $28, and which is not good. So that's why they came up with this concept of gas. Gas is related to ether, and when you execute transaction you pay in terms of gas. Okay, so ether is main, and related to ether there's another subcurrency which exists only in terms of transaction, gas. You can't buy gas, simply you cannot go to Ethereum exchange, you can buy gas now. Gas is bought by ether, but only at the time of doing the transaction. So for now, I know this, if you are hearing all these terms for the first time, it might get confusing. But for now, don't worry. We will go, I'll try to explain into more detail. But for now, just take it this way. Ether is nothing. Ether is a cryptocurrency running on Ethereum. That's it. What is gas? Gas is a currency which exists on Ethereum. Okay. But only when you are doing transaction. The scope of gas is not outside of transaction. When you try to do a transaction, you give some ether, automatically it will be converted to gas, and accordingly transaction will happen. How all this thing happen, I will go into much more detail slowly, but for now let's stop that. Okay, that ether is nothing but a cryptocurrency, gas is nothing but it is also currency, but only for the transaction. Let's start talking more about transaction. And I think this is like most of our time today I will spend on this transaction, because we need to understand this transaction properly in order to understand anything else. Sorry, excuse me. Okay, all right. Also, so what I thought is, in last few session, in any other session, everyone keep talking about theoretical. What I thought today is what I will do today is I will show you exactly how these transactions work. So I'm not going to talk any more theory. I will show you in reality what all these things are, how Ethereum, how transaction works on Ethereum. Okay. So I have a Geth running. This is my standalone Geth. It's not connected to any network, not on main network, not on private network. It's just a standalone Geth which I have running on my server. Okay, and before going there, let's talk a little bit theory of transaction, and then whatever we talk, I'll show you practically. Okay, so transaction can be of several types. Oh, 1 second, I go there, write something. So if I say transaction, once again, I'm increasing the font. So they can be, first of them, there can be a transaction which is initiated by the user. User is nothing but you. If you have a account in on Ethereum, you can initiate a transaction. Okay, so that's one type of transaction, when the transaction is initiated by a user. And there's second type of transaction where a transaction is initiated by the contract. Okay, under user there can be two type of them. There can be a transaction which is initiated by a user and it ends up on another user. That means that this transaction will transfer Ether from user A to user B. Okay, so this is a very simple type of transaction where I'm instructing Ethereum that okay, transfer this much of Ether from user A to user B. And there can be any another type of transaction where user A sends a transaction to a contract. So what will happen in this one? I as a user, and this is the second one is the most complicated one, which we will talk into very much more detail, and I'll show you practically today. In the second type of transaction, there is a user, and this user will initiate a transaction asking the contract to do something. Or to be more specific, user A will initiate a transaction to call a function of this contract. And again, let's don't get confused. I will show whatever I'm saying, I'll show you practically. Then under contract, again, it can be two type of it. There can be a contract where contract A can transfer Ether to contract B, or there can be a transaction where a contract A can call contract B. So these are few like these are types of transaction which can exist on Ethereum. So a transaction can be initiated either by a user or it can be initiated by either by a contract. User as well as contract are capable of initiating a transaction. In other words, user as well as contract are able to do or are able to change the state of the Ethereum. Again, if these terms are new to you, as I keep saying, as I show you practically, things will get more clear. Okay. So that's the only theory about transaction. We will concentrate on this particular transaction because this is the most complicated transaction. If we can understand this one, then I'm pretty sure we can understand the rest of it. Okay. I will increase the font a bit so that you all can see. And also, my aim is not that you all follow me. I'm pretty sure you don't have Geth running in front of you. The aim of whatever I'm going to do for next 30 minutes is that I will do it. We are recording it and we will publish it so that you all can see. And then, based on your time availability and everything, you can try it later on. And still, if you have question, then feel free to join our Slack and post question there. We will be more than happy to answer you. But for now, I'll just keep on doing it to show you that how it works, and then you can try it later on. Okay. So now even before going there, let me show you a very simple contract. Here's how a contract look like. As I said at the very start, contract or smart contract is nothing. It's just a piece of code, and this is written in Solidity. Solidity is more or less derived from JavaScript, so mostly it follows the same procedure. We will be talking Solidity more in coming session, but today we are concentrating only on transaction. So again, this is how a contract looks like. The very first line tells that which version of Solidity you want to use. Okay. And then any contract start with contract add, contract and the contract name. Sorry. So it start with the keyword contract and there's a contract name. Then this is how you define a variable. And this is a very simple contract. And what I'm trying to do in this contract is I'm trying to add two numbers, and at the same time I'm trying to return that number. Okay, so the exercise which we are going today is I'm going to show you that how to compile this contract and how to call this contract on Ethereum. But the way I'm going to do is it's a hard way to do it. If you are going to, like, if you want to do it, there are many easy way to do it, but I want to show you exactly how it happens. For example, I'm pretty sure you all must have used a Visual Studio or something here and there, like some of the Visual Studio or editor of Java or something, where they give you interface. So there are tools available for Ethereum also, but here I do not want to show you the tool, but I want to show you exactly what happens on Ethereum when we say a transaction gets created, how the transaction really gets created, how transaction looks like. so that you understand what Ethereum is, you understand what transaction is. You are not on the, so you are not on some layer, but you are on level 0, where you can do, or you can do debugging as required in future whenever you are developing a code on Ethereum, or whenever you are doing anything on Ethereum. Okay, so this is how you write a contract. So suppose you have a contract ready, and here's a contract to add two numbers. Okay, what you do, take this contract and go on internet and find any line removal, or remove line breaks or paragraph breaks, because you want, in order to compile it on Ethereum, you want to remove all the line breaks, you want to remove all the paragraph breaks. Okay, so take this contract, go on, you can use this one, I'm using textfixer.com, but if you search, you'll find number of them. Okay, come and paste it here. This is the contract, and I'll say remove line breaks, and all the line and paragraph breaks are removed. Okay, just give me one sec. Everything is removed. Now let me copy it. So this is my contract, and now I'm on Geth. I have two accounts here. This is the main account, and this is account number 1. So for deploying and everything, I'm going to use this first account. So as a first step, let's compile let's compile our contract. And in order to compile it, and again guys, I'm doing it live, so I might go wrong here or there, but I'll try to fix myself as soon as possible. If not, then sometimes later on. But since it's a live session, so just bear with me. Okay, uh, so you have this. Okay, here you go. So I just copied the contract where I've removed all the line break and paragraph break. So let's define a variable. Okay, where I want to, first of all, I want to store the source code. So what I'm doing here, I have defined a variable called source code, and simply I'm just storing the source code. Okay, when it comes undefined, it means it's done, it's all good. So if I do like this, source code, you can see the source code is stored here. Okay, now that's step 1. As the next step, now let's compile it. And in order to compile it, again, let's define a variable, compile code. Okay, and command is it dot compile dot solidity. Make sure you have solidity as well as Geth installed on your server when you're trying to do this thing, because generally you install Geth, you don't install solidity. Make sure the solidity is also installed. Okay, and this is the source code. Okay, good. So what we have done, we have compiled the code. If you will see, you see here, this is how I compiled it. Okay, and now I'm seeing this compile code. Okay, so if everything goes well, this is how you see it. This is your code. Here, this is the most important part, ABI definition. I'll suggest you all take this word ABI definition and read on it over internet what it is. It is basically an interface, okay, which helps you to talk to Ethereum contract. I won't be covering ABI definition here because it's just some theoretical part which you all need to understand, and I'm pretty sure you will find a whole lot of definitions over internet. Okay, and rest of the thing is like just generic. You can study like language we use, solidity, version, source, and all those things. Okay, so this was the real source, and this is the compiled code. This ABI definition, this is the most important part. What you see here, this is not the real ABI definition. What Ethereum do, it 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 hides it here. It's hide it from showing here. It does not show here because it's a big value. All right. So and plus you need ABI definition in order to interact with the contract. So now if you want to see the ABI definition, you can do it this way. I have this command called compile code, and then take this part stdin colon add info.abi definition. Also be careful. Recently, Solidity has made a change, and I posted in the Slack also what change was, and because of that change, everything was breaking. Initially, this stdin did not used to come here, but recently with the new version, this started coming, and that's why lots of stuff started breaking. Yeah, you were facing compilation issue. If you were using the tool needs to be updated because suddenly this starts coming up. So be careful when you are using this command. This is how you need to use it. Okay. So before it used to be compile code dot add dot info dot ABI definition, but now it is compile code stdin colon add in dot info dot ABI definition. And if I click enter, you see this interface. And if you study it carefully, this is nothing. It's just saying that, okay, name add, which is type function. There's another function, the name return add, what type of return it is. So basically, ABI definition is nothing. It is just an interface to your contract. And using this ABI definition, you can call your contract. Okay. So that's it on ABI definition for now. I'll suggest you all to read more about ABI definition. This is important if you want to do deep dive into programming word of API. Okay. So far we are good. This is how ABI definition looks like. Now, as I said, this ABI definition helps us to interact with the contract. Okay. And now how it helps, I'll show you. We need to create an object just like any programming language. Okay, this is ABI definition, this was our contract. So we need to create an object which will help us in order to interact with our ABI definition. Sorry, I don't know, I said object or contract, so I'm repeating myself. So we need to create an object in order to in order to talk to our contract, and that we can do. Just give me 1 sec. So let's define another variable, add contract. Okay, and then it dot it dot contract, and compile code. Let me take it from here itself. Okay, so it dot contract. Let me move it up. Compile code std and this info.abi definition. So what we are doing, we are just creating an object which is nothing but the ABI definition. If everything goes well, we get undefined. So means everything is good. So this is how we create an object. And if you want to see, its object is nothing but if I just write add contract and click it, this is how object will look like. So it contains the ABI definition, also couple of other stuff. So I'm not going to go into step by step. This is all the backend stuff, but it's always good to know that what is happening on Ethereum. So this is how it will look like. This is how the object will look like if everything goes well. Okay. So far what we have done, let's summarize it. We have taken the source code. What we did, we took a contract, we stored it in a variable called source code. Then we took another variable called compile code. We compiled the code and stored into the compile code. Okay. We saw how the ABI definition look like because ABI definition do not come when we see the compile code. Then we created an object which will help us to interact with the contract. Okay. That's what we have achieved so far. we have yet not deployed the contract on Ethereum. Again, I'm repeating, so far we have compiled the contract, we have created the object, but we have not deployed the contract on Ethereum. Okay, so now let's deploy it. But how to deploy it? Now I'll go back like where we started, transaction. You need a transaction in order to do anything on Ethereum. So if you want to deploy a contract, you need a transaction. Okay, so again, I'm repeating myself because it's very important. Anything if you want to do on Ethereum, you need a transaction. What we want to do now, we want to deploy a contract. We want to tell Ethereum that, hey, here's the program which we want you to store in your blockchain or wherever you want to store. Okay, but in order to do this thing, we need to create a transaction. And again, if you would have been using a tool, you must have simply written something like, if you are using Truffle, so Truffle migrate or something, which would have done all this thing for you. But since we are doing the hard way, where I'm trying to show you that, okay, these are all the steps involved. That's why we are following all those steps. In reality, it won't be this difficult because all these things will be taken care by the tool. So now I'll show you how the transaction will to deploy the contract will look like. So here's how it looks like. You say you define another variable called add transaction. Okay. And then you say add contract dot new. And now you have to tell, these are now generic thing which you have to specify for any contract, that from where, from which account you want to deploy. So we are saying account number 0, and that account is also called eth.coinbase. It's actually not always account number 0. The Coinbase is the account where miners get their reward. In my case, it is account number 0. Then I'm telling what data to deploy, or in other words, which contract to deploy. I'm telling if I want to transfer any value to the contract. So here, while deploying the contract, I can also transfer certain ether to my contract, but I do not want, so I said 0, and this is the amount of gas which I want to spend in order to do the transaction. So now you see, initially I talked about ether and gas, and I said that in transaction world there will be a concept of gas. Here's the concept of gas. So what I'm doing is I'm supplying this much of gas, and whichever miner, okay, will execute my transaction will get all this gas. Actually, it will not get all this gas. Ethereum protocol will evaluate that how much of real gas is needed in order to execute this transaction, and that much of gas will be transferred to miner account, and rest of the gas will be returned back to me. So generally you specify some big value, because just in case, suppose I provided 100 gas only, okay, and this entire transaction is going to cost me 200. So what will happen is this Ethereum will start executing this transaction, okay, and there will be a time where 100 gas will get exhausted, and still the transaction is not done because transaction is 100 more. What Ethereum will do, Ethereum will stop there, will transfer that 100 gas to the miner, and it will tell back, and it will tell you that you reached gas limit. Might be that error is wrong, but it will tell you, it will give you some error, and you will use those amount of gas also. So you have to be judicious enough to provide sufficient gas that transaction can be done completely. And if you are providing any extra gas, it will come back to you. So this is how transaction look like. What more I have done in order to catch the error in the contract, this is how I've defined a function. There's nothing to explain. This is a just simple JavaScript, which you can, on the video, you can simply take a look, or, we are more than happy to send these stuff over Slack. So if I press enter, you see you get an error. For now, error, authentication needed, password unlock. And that's the beauty of Ethereum. No one can simply go on your get server, or no one can simply, go and execute the transaction. You need to unlock the account. Again, if you would have been doing this thing through some tool, then it might have asked you to enter your password. But since we are doing in a raw way, so it just said that it needs a password. So what you will have to do, you will have to unlock your account. So let's unlock our account. In order to unlock your account, you do it.accounts to see, sorry, it.account. As I said, I'm using this account, so let's unlock this account. Personal.unlock. You give the account detail. It asks for password. I'll enter the password. Good. So now my account is unlocked, and let's try it again. So again, this is the transaction to deploy the contract. I'll press enter, and you see a transaction got created. Okay. And now if you want to see see what it is, so let's copy this transaction. And now you can use this command it.get transaction, enter the transaction detail. Oh, sorry, I copied too much. It's still here. So it.get transaction. Now what happened? Oh my god. Sorry guys, 1 second. It dot get transaction this hopefully, yeah, here you go. So whenever you execute a transaction, this is how it goes and resides. Still, it is not on blockchain. And why I say it's not on blockchain? You see the block number is null. But otherwise, it's showing you all the information that this is the gas, this is the gas price, this is the input, these are RSV, these are the value, in order to prove that this transaction belongs to you. So let's not go into all those details. But what I want to show here is, you see block number is null. And why it is null? Because I'm not mining. Here on this get, I have not started the miner. So transaction is still in pending stage. And this is okay. So what I did, I initiated a transaction, but I did not started the mining. So Ethereum did not tell me anything. It just said, okay, Ethereum has taken the transaction, but until unless there is not a miner, things will not happen. Things will not go into blockchain. So for people, whenever they hear about miner, everyone thinks about cryptocurrency and this and that only those, during that time only miner comes into picture. No, role of miner is much more than managing the cryptocurrency part. And that's what lots of people do not understand, because for everyone blockchain is nothing but is like, for them it start with cryptocurrency and it's end with cryptocurrency, but that's not true. Cryptocurrency is just a part of it. In order to execute your contract, in order to call your contract, in order to do anything, you need miners. Okay, so the role of miners in Ethereum world is huge. Again, not only miners not only have to do with cryptocurrency, but they have to manage many more things, or they do many more things. Okay, and one of them I'm showing you right now. If there are no miners, you will be able to execute a transaction to deploy a contract, but nothing will happen until unless miners don't start mining. Okay, now let's start mining here. As soon as I'll start mining, you will see this transaction will get mined, and Ethereum will give you an address, and that address will be a unique address of this contract using which I can call the contract. So again, I'm repeating myself. As soon as I will start mining, you will see this transaction will get mined, and at the same time Ethereum will return you with the unique address using which I can call this contract, because you need a unique address, right, in order to call the contract. You do not know where this contract is going to be saved. That will be done by Ethereum. So what Ethereum does, it gives you a unique address. So let's start mining. Okay, and here you see, now let's stop this mining, otherwise too many things will keep on coming. Okay, here you go. So it started mining. You can see mine potential was 50-50 and whatever. This is the important part. You see, our transaction got mined successfully, and Ethereum has returned us a unique address back, and using this address we can call our contract. And let's see how we can call our contract using this address. So again, to summarize, so far we took our contract, we compiled the contract, and at the same time we deployed the contract, right? And now we are going to call our deployed contract. So that's like with any function, right? You write a function or you write a program, you execute the program, then you deploy it, and then you have to call it. So it's the same thing which we are going to do. Okay. So hold on, just give me 1 second. Also, now in order to make sure that this is really your contract, what we can do is we can define another variable called code binary, and that we can make it equal to it dot get code, or before that, hold on a second, let's store this address, right? Otherwise, so what I will do is I will take this, I'm just storing this address in a variable so that I don't have to copy it again and again. And once it is stored, let me do this. Let me show you how to prove that, okay, this is really the contract, okay, which you have just deployed. Code binary is equal to it dot get code, and then this is the address, okay. And now if I want to see code binary, here you go. And now what you can do is, 1 second, just give me 1 second. Okay, that variable was compile. What was the name of that variable? Compile code. Yeah, I think it's sorry. Okay, compile code. Okay, so this was the variable, right? This is how we compiled it, and we have stored in the compile code, and this was the code. And now I did again, like what I did, I got the same code by starting with the address. So compile code was done initially, and this was the later part where I deployed the code, and then from the deployed code I'm trying to get the binary. If you match this two, you will see most of the things are in common. I'm not going to match here, but you feel free to match it. You will see most of the stuff are in common. Only some starting part will be different. And why it is different is, if there is a constructor in your program, the constructor is not stored by the block by the Ethereum, because it you need to, because constructor is executed just once. Okay, so whatever needs to be executed just once, you won't see it here, but you will see it in the compile code, and you can see, you can do the diff, and you can compare it, but rest of the part you will see as is. If you compare the last few things, see, is the same thing. So that proves that this address really belong to the contract code which you deployed. And again, here I'm just doing one transaction, one contract, so it does not make any difference. For sure it's the same thing, but if you are working on the main network, or if there are many transactions coming in, so this is how you can compare it, that okay, really this is the address of your contract. Okay, so again, so far what we have done, we have taken the source code, we have compiled it, and we have deployed it. We have also seen the transaction. Okay, okay, one more thing I want to show you. You remember I just showed, before I showed you it.get transaction, and this block number was null. Now let's do it again. If I do it.get transaction, you see now the block number is coming, and which proves our transaction got mined successfully, and our transaction is on block number 50. Okay, So before, when I showed you, it was null, and now you see a block number has come, which proves that okay, our transaction got mined successfully. All right, just give me one more second. Okay, so again, so far we have compiled the contract, we have deployed the current contract, we have verified that okay, address is, we got the address, we stored the address, we saw the transaction. Okay, now let's call our contract, because what's the use of contract if we cannot call it, right? Like, you need to call, you need, the contract needs to do what it is designed for, otherwise why do you want even to deploy it? So let's start calling our contract. Now in order to call the contract, take the contract as a class, right? The way class work. So when you deployed the contract, you created a class. Okay, now in order to call that class, just like in any in C++, Java, anywhere, you need to create an instance, right? You need to create an instance of that class. So let's create an instance. Variable add instance, that's the variable name. Then add contract dot add. So what I'm saying, take the contract which is add contract dot, which is add address, this, right? And this is where our address is stored, right? At add address. And if I click this one, at undefined, that means a instance got created. Good. Now let's call this contract using this instance. And how to do this thing? So let me quickly show you this function. So what we are going to do is we are going to call this function. So we are going to call this function called add, and these are the two parameters which add need. So add needs a number a and number b, right? So that it can do the calculation c. C is equal to a plus b, right? So we are going to, again, we are going to call this function add, and we are going to pass two integers to this function. So let's do this thing. Add instance. Okay, that's the instance which we created. We will use a dot operator, then name of the function, which is add, right? So what we are saying, take this instance and we want to call this function add. Okay, create a bracket, press enter. Okay, now you need to provide the parameters. What are the parameters? A and B. So let's provide any two number, 2 comma 3. Good. Let's give one more comma n. Now again, this is a transaction, right? So we have to tell from where this transaction is coming. So we have to tell that okay, from, use this account to charge if you want to charge. So this is the account address. Let me copy it here. This, let me close first bracket, let me close second bracket, colon, and if I press enter, password required. Good. So let's provide, unlock the account. It unlocked the account. Now let's try to do it again. There you go. What happened? Again a transaction got created. And if you want to see this transaction just like last time, it dot get transaction, take this transaction. So again, it's not mined because I'm not running the miner. So this is still a pending transaction. So if I do it this again, you will see a block number, means nothing is mined, but still it's sitting in a pending state. We pass this gas with this gas price and all those information, you can see it here. Okay, what I will do. So what we have done so far, we tried to call our contract using a transaction because everything needs to be done using a transaction. Okay, we try to call a transaction. That's how we okay, sorry. We tried to call add function using a transaction. This is how we created a transaction. Okay, which created a transaction, but since mining is not happening, so it went to the pending stage. Let me start the miner again. Start miner.start, and very soon it should get mined. Did it got mined? Let's wait for a few more minutes. think it got mine. Let's see, it got mine or not. Miner dot stop. Oh, miner dot stop. Okay, I stopped the mining. Let's check that it dot get transaction again. Here you go. You have the block number that proves okay. This time Ethereum did not return any address, just like last time, because last time we deployed a contract. Only when we deployed a contract, then only Ethereum reserved with a unique address. Here it saw that this contract is not deploying any contract, so it will not return you any address. But what it did, it deployed the payload. What payload is? Payload is this data, that 2 and 3. So if everything would have gone well, then at this point of time, what Ethereum has done, let's come back to the contract. It has taken these two integers, that is 2 and 3, and would have executed this function. And what does function do? C is equal to A plus B. So at this stage, the value of C in Ethereum would have been set to 2 plus 3 is equal to 5. And now how to verify it? That's why I have written this another function, return add. What this function will do, it will simply return the value of C. Okay, so just like last time, let's create a one more transaction. Hold on. In order to see the value of C, and in order to do that, what you need to do is, again, let's take this instance, add instance dot return add. Here you need not to pass any parameter, it does not need any parameter. And also I said this is a constant function. What it means, this function will not update the state of the Ethereum, but will only return a value. This constant keyword is quite important. Every transaction, as I said, costs you something. But when you say it's a constant, this transaction will not cost me anything, and you don't need miner. What I'm saying to Ethereum is that, hey Ethereum, we are not changing your state, but I just need a value, but I'm just retrieving a value. I'm not doing anything with your blockchain, but just tell me what is the value of this variable C. Okay, and that's what is being done by this constant. So now when I will execute this transaction, it will get executed right away, because I'm not changing the state of the blockchain. Okay, I'm just asking, just tell me the value of this value, sorry, the value of this variable C. Okay, so let's do it. Return add, and I have to just, but I have to tell them that which account is calling, although this account will not be charged, but with every transaction I have to tell that, okay, which account wants to execute this transaction. Here you go, let me close this, and if everything goes well, there you go, you see 5, right? So what we did, we passed 2 and 3. Okay, and then we try to retrieve it. If you want to do it again, we can call that function again. I will have to write everything again, we don't have time. But yeah, what you can do is you can keep changing on this value, and if you call this thing, you will see, the value will keep on changing. Add instance, and this is an immutable, all those things whatever we've done is immutable as long as this blockchain will live, right? And this value will always reside there. And as I said, when we executed this particular transaction did not need a mining to start, because we are not changing the state of the Ethereum, but we are just asking Ethereum to return some value back to us. Okay, so sorry, this was a long one, but you see, right, I wanted to cover this entire thing in one shot, and that's why I said, like, let's not ask any question, let me finish this thing, and then we can continue with the question if we have time. Although we don't have time, but for a couple of minutes, if you guys have any question, feel free to ask any question. But we have like just couple of minutes. Actually, I have back-to-back meetings, so I have to run. But you see, right, this is how transaction work, this is how you can deploy the contract, and this is all you are doing in a hard way. There is a much simpler way to do all those things. We can go there, but it's always good to see the back door, right? Because you will not find all these things whatever I showed you anywhere on the internet in such an easy way. So this is important to see how Ethereum works. Why we keeps on saying that, okay, miner, which I try to emphasize, right? Miner is not to do only with cryptocurrency, there's a whole lot of things miner does in order to keep this Ethereum working, right? So I think I've showed a very good relationship between transaction, between contract, between mining, and how you can see all those things live. So whatever we keep on talking about blockchain or Ethereum, it's not theoretical, it's all practical. The best part is you can see each and everything what we talked about Ethereum. So my suggestion is don't ever read just the theory, always try to play it around. So we will publish this video, take a look, go through it. All the commands are there. If you need anything, we are more than happy to put stuff in our Slack, okay, from where you can get the commands, or if still you have question, feel free to ask us anything on Slack. And in our next session, we will continue with the rest of the topic, right? Like, I do not know what we will start, but smart contract or EVM, which is the EVM virtual machine Web3, and all those things will continue on. But this is the very base. You need to understand transaction before going further. So I will stop here. If you guys have any question, maybe we can, for 5 minutes, we can talk about it. Otherwise, yeah, that's it. Okay, I think either I explained it very well or I did not explain anything. So do let us know. Well, at least do let me know your feedback. If it was too technical, then also let me know. But my aim was that this session was going to be technical, and that's why we said deep dive. There will be other session where we'll be talking light topics, right, like use cases and business side. We will touch that part also. But today we thought, to do a deep dive so that at all our wonderful coders, who are interested in coding and developing Ethereum, they can get started. And also a prerequisite before you do this thing, you install Geth, you install Solidity on your server. Okay, then only start doing all those things.